My name is Shruti, research scholar from Department of Civil Engineering. So today we are having two tutorials, 3 and 4. Tutorial 3 is related to extreme event analysis and tutorial 4 is HECRAS and HHMS. So I'll give a brief idea of what is tutorial 3. In that we are mainly focusing on extreme event analysis. So extreme event analysis, we are concentrating on drought analysis. How to do drought analysis in RStudio. So in yesterday's class already the definition of drought, different types of drought, what are the different indices used for the calculation of drought events, and the case studies already discussed in yesterday's class. So I am not explaining that. So in RStudio we'll have one package name SPEI. Using that package, we can analyze meteorological drought. Mainly in SPEI package, we can analyze both SPI and SPEI. These are the most commonly used meteorological drought indices. That is standardized precipitation index and standardized precipitation evapotranspiration index. These two indices we can calculate using SPEI package in RStudio. So the major difference between these two indices are, for SPI we will use only precipitation data, and for SPEI we are using both precipitation as well as temperature data. That is, we will convert that temperature data into potential evapotranspiration, and that potential evapotranspiration is used for the calculation of SPEI. So these are the packages required in RStudio. Packages available in RStudio for analyzing this meteorological drought. So SPEI is the package used for analysis of SPI and SPEI. Also I am doing the trend analysis of this SPI or SPEI series, time series data. So first we need to install these packages, that is read Excel, write Excel, SPEI, trend and trend changer. That read Excel and write Excel means we need input, we are providing input data in Excel format. So we want to read that data. For that we need a read Excel package, and the output is say okay, output we are saved in an Excel file, so that we need a write Excel. That package is needed. So after that we can load these packages. Then next, first we need to prepare our input data. I prepared my input data in an Excel sheet. In that sheet I have data. I will show you my input data. This is my input data, that is year, month, then rainfall and mean temperature data. I collected this data from GLDA's website. If you have data IMD gridded or station data, you can use that data. Here I collected my data from GLDA's website, and the link for that site is also provided here. In that site you will get gridded data, that is soil moisture data is available, evapotranspiration data is available, groundwater data is available. All this data is available in this website. That's why I took precipitation and mean temperature data from this particular site. So after that you can call your data, that is the input Excel sheet we can assign to a variable data. After that we can create a proper date column, and rainfall values can be converted into time series. That is not necessary. If you want, you can convert that data series into a time series. The use of this is because in SPEI package, after calculating SPI and SPEI, we can plot graph. So that time, if you want that x-axis, that year is coming properly, if you give it as a time series data, otherwise it will come as numbers only. Because here I used data from 1980 to 2020. If you want that year come in x-axis, you need to convert the data into time series format. That's why I converted my data into time series. After that you can calculate SPI and SPEI. So this is the code for SPI. You can calculate SPI for different time scales, that is 3 months, 6 months, 12 months, etc. And in SPEI packages, distributions are available for fitting this data. That is gamma distribution, log logistic distribution and Pearson type 3 distribution. These are the three distributions available in SPEI package. So for the calculation of SPI, the default distribution is gamma distribution. That if you are giving data, rainfall data, that data is fitted to a gamma distribution by default. If you want log logistic distribution or Pearson type 3 distribution, then you have to provide like this. Distribution is equal to log logistic. Otherwise, distribution is equal to Pearson 3. If you are giving like this, that is RF underscore PS is my input data. That is rainfall time series data. That comma 3 means a time scale. That is 3-month time scale. 6 means 6-month time scale. 12 means 12-month time scale. In first, I didn't give any distribution. That means my input rainfall data is by default it is fitted to a gamma distribution and it will give SPI values. So after that we will get SPI values and we can save that in an Excel sheet. So this is the expected output. I prepared that output Excel sheet and the output you will get like this. Year, month, rainfall, SPI 3, SPI 6 and SPI 12. Here SPI 3 is fitted to gamma distribution. SPI 6 and SPI 12 is fitted to log logistic distribution. In that way you can calculate SPI 3, SPI 6 and SPI 12. Also you can plot this graph. That is, this is the function for that. Plot SPI 3, plot SPI 6, plot SPI 12. Then you will get the temporal variation of SPI. Here we will get the time as 90, 80, 90, 90, 2000 like that. Because I converted my data into a time series data. Otherwise here you will get 1, 40, 50 like that you will get. If you want that year, you need to convert your data into time series data. Then you will get like this. So this is SPI 3 result and these are the result for SPI 12. So in that way you can calculate SPEI also. For SPEI we are using both temperature as well as precipitation data. Temperature data, first it is converted into potential evapotranspiration. So here I gave my input as mean temperature data because in GLDA site we will get mean temperature data only. But I think in IMD we will get Tmax and Tmin. In that case you can calculate some. Here I used Thorndike equation for calculating the potential evapotranspiration. If you have maximum and minimum temperature data, you can use Hargreaves equation. That is also available in this package. If you have solar radiation data, wind speed data, you can use Penman-Monteith equation. That is also available in this package. Here I am having average temperature data. That's why I used Thorndike equation for calculating potential evapotranspiration. So potential evapotranspiration is calculated using Thorndike equation. I have average temperature data as well as we need latitude of that particular point. Here I used the grid point. My latitude is 8.375 degree north. So I used that. So it will automatically calculate potential evapotranspiration. Then rainfall minus that potential evapotranspiration. That data is fitted to an appropriate distribution and from that we will get SPEI value. Here also I did for 3 time scales, 3 month, 6 month and 12-month time scale. So you can plot SPEI 3 also using the same function. So this is the expected output. We will get year, month, rainfall, temperature, potential evapotranspiration. We can get the potential evapotranspiration also using that Thorndike equation. Then SPEI 3, SPEI 6 and SPEI 12. That is not SPI, SPEI. So this is the plot of SPEI. So after calculating these indices, SPI and SPEI, we can calculate the characteristics of a drought event. Characteristics means its duration, severity and peak or intensity. So for each drought event, we can calculate the severity of a drought event, duration of drought event and peak value. Here I am concentrating only duration and severity. Actually this I took for Coppola analysis, we are doing multivariate analysis. That time we need this data. That's why here I calculated severity and duration. So severity of a drought event means What is severity? Sir, already explained in last class, yesterday's class. What is severity? That is a cumulative negative SPI values, because in SPI time series, if the value is less than 0 represent a drought event and greater than 0 represent wet event. So the cumulative sum of that negative value represents severity, and how many months that particular event lasts, that represent its duration. So based on that, I calculated duration and severity. So this is the code for that. That the initial value I given as 0. Whenever SPI value less than 0, the drought event starts. In that way, we can calculate severity as well as duration. So the output also saved in a Excel sheet. This is the duration, severity. That is the starting of a drought event, end date, its a duration and the severity of that particular drought. After that, I did a trend analysis. So for that, we are using that package trend. In that package, we can calculate Mann-Kendall trend test as well as the sense slope related to it. So this is the code for that, mk.test data3 SPI3. So we will get the trend analysis, Mann-Kendall trend analysis of SPI3 time series. If you want to check the trend analysis of rainfall, you can do that also. So in that you will get a Z statistics value. Here I am doing 95% confidence level or 5% significance level. In that, if p value less than 0.0 represent significant trend. In that you will get one Z value also. If Z value is greater than 0, it represent increasing trend, and Z value is less than 0, it represent decreasing trend. After that you can calculate sense slope estimator also. Then innovative trend analysis. This is also one way of detecting trends. Here the major difference between Mann-Kendall trend test and the innovative trend analysis is, in Mann-Kendall trend test, it is based on a hypothesis. There we will assume null hypothesis as there is no trend in the data series, and alternate hypothesis there is a significant trend. But here it is the visualization. Graphically we can say whether trend is there or not. Here the data is divided. I have a 40 years data. That data is divided into two segments. First 20 years and second 20 years. And first 20 years is represented in x-axis and second 20 years is represented in y-axis. And here 145 degree. Here 145 degree line is there. After you calculate innovative trend test, you will get an output like this. In that, if the data points are above this line, it means that a increasing trend, and if the data points are below that line, it means it is a decreasing trend. Here I did it for SPI and it shows a decreasing trend. That is decreasing trend in SPI time series. That means the severity of drought is increasing. That Navin sir explained yesterday. That is, here drought is SPI values shows a decreasing trend. It means the severity of a drought is increasing. So this is the result. So I also included petty change point test. This is for rainfall to check homogeneity. So this is regarding drought analysis. Next is copula. Are you aware of copula? Anyone is working in this? So, copula, it is a statistical tool which is commonly used in hydrology for multivariate analysis. That is, multivariate analysis means the major application of copula is, in my case, if I calculated the severity, duration, peak, the characteristics of drought. So I can't explain only based on severity how much drought a particular area, because if the duration is high, it will create some other problem. So sometimes some other application is, In the case of a flood also, you have flood peak, flood volume. Based on a particular variable, we can't say the risk associated with that. So we want the combined effect of that. In the case of drought, we want the combined effect of severity, duration and peak value. In that cases, we are using copula. The other application, if you want to study compound extreme events, if you want to study compound drought and hot events, in that case also we can use copula. That is, here we will calculate the joint distribution. So, if you want to calculate the joint distribution of two or more variables, we are using copula. So copulas are mainly of two types. They are elliptical and Archimedean copulas. Both these copulas are used in hydrology. This elliptical copula mainly used for symmetrical dependence, and Archimedean copula mainly used for asymmetric dependence. Do you know what is symmetric and asymmetric dependence? Anyone knows? Symmetric dependence. So symmetric dependence means if I have two variables, that is temperature and ice melt. If there is higher temperature, then ice will melt. Both are depending. So if high ice melt, I can say the temperature is high. That type of dependence is symmetric dependence. What about asymmetric dependence? Any example? Asymmetric dependence. Anyone? That is pollution and health problems. If there is pollution, it will cause some respiratory diseases. But respiratory diseases won't cause pollution. That is asymmetric dependence. This is a simple example for symmetric and asymmetric dependence. So, for symmetric dependence, we are using elliptical copulas. Elliptical copulas consist of Gaussian copula and student T copula. And for asymmetric dependence, we are using Archimedean copulas. It consists of Clayton copula, Gumbel copula, Frank copula, Joe copula. These are the different types of copulas mainly used in hydrology. So, how we will do it in RStudio? So, we have one package called copula. Using that package, we can calculate the joint distribution. So, here I am having two variables, severity and duration. I will say how to do it in RStudio. First, you have two variables, severity and duration. First, you need to calculate the CDF corresponding to severity and duration. For that, first you need to find the best fit marginal distribution corresponding to severity and duration. Using the best fit distribution, you can calculate the CDF of severity as well as duration. And using copula, you can calculate joint CDF. This is the procedure. So, first you need to fit your severity and duration to appropriate distribution. For that, we can have one package, FitDist Plus. It is available in RStudio. So, using that package, you can calculate the best fit distribution corresponding to severity as well as duration. So, first step is fit appropriate marginal distribution. Here I took only three distributions, that is gamma, log normal and Weibull distribution. So, I used these three distribution, and from that the best fit distribution corresponding to severity and duration is calculated. So, here I used AIC and BIC values, that is archaic information criteria and Bayesian information criteria. These are the, we will get AIC and BIC values. This is to check the goodness of fit test. If you are interested to do other tests like chi-square test Anderson-Darling test, KS test, you can use that also. Here I use the AIC and BIC values. The distribution which gives minimum AIC and BIC values is the best fitted distribution. In that way, we are taking the best fitted distribution. If you are using other test like a KS test and Anderson-Darling test, in that you will get one p statistic value. The distribution with the minimum p value is the best fitted distribution. In that case, here the minimum AIC and BIC value is taken as the distribution which gives minimum value is taken as the best fitted distribution. So, the best fitted distribution is based on minimum AIC and BIC values. So, similarly, we can do it for duration also. After getting the best fitted distribution, we can calculate a CDF. So, I saved my CDF data. This is the expected output. Severity, corresponding CDF, duration and corresponding CDF values. So, next step is using the CDF of severity and duration. Next, using copula, I'll calculate joint CDF of this. So, there are different types of copula is available. Gaussian copula, Clayton copula, Gumbel, Frank and Joe copula. These are the 5 types of copulas I used. And using this copula, you will get the joint CDF. From that, you can find the best fit copula for your distribution. So, here also I used AIC and BIC values, and the one copula which gives minimum AIC and BIC value is taken as a best fit copula. So, compute joint CDF. So, after getting joint CDF, this is the AIC and BIC values. This is the joint CDF. After getting joint CDF, you can calculate the joint return period of drought events. That is, from the joint CDF, you can calculate joint exceedance probabilities corresponding to different percentiles. Here I took 15th percentile, 75th percentile and 85th percentile. So I calculated joint exceedance probability corresponding to these percentiles, and using that joint exceedance probability, I calculated return period. So finally you will get a return period corresponding to this exceedance probability. So in this way you can calculate the joint return period. So if you have peak value, then you can use severity, duration and peak. This is the way you can do multivariate analysis.